Now let's consider the autoionization of water. We've seen that water can act both as an acid or a base, depending on what's present. So in this case, one water molecule will act as an acid and another will act as a base. So this first one can act as an acid, and it can transfer a proton to the second water molecule, which acts as a base because it's accepting the proton. Then we'll have H3O plus OH minus. So this is called the autoionization of water. Okay, so we can write our equilibrium constant for this reaction as the concentration of the products divided by the concentration of the reactants. But the reactant concentrations are both water in the liquid phase, and the products are in the aqueous phase. So we don't include the liquid phase here. These are just constants for the concentration. So we call this Kw when we take the denominator, which would be water squared concentration, and move it over to the left and multiply it by the equilibrium constant. So now we have K sub W. W stands for water, and it's just the concentration of H3O plus and OH minus. In pure water, Kw is 10 to the minus 14th at room temperature. So that means since we have one H3O plus and one OH minus, then each of these concentrations would have to be 10 to the minus 7th, because that product would be then 10 to the minus 14th. So each of these is 10 to the minus 7th molar in pure water. So the pH in pure water, defined as being negative log of H3O plus, which equals negative log of 10 to the minus 7th, which equals 7. So the pH in pure water is equal to 7. So 7 is said to be neutral. So one useful thing of the autoionization of water is it allows us to calculate the concentration of either H3O plus or OH minus if we know the other concentration. So say we know the concentration of H3O plus is equal to 10 to the minus 3. What is the concentration of OH minus in water? Well, we have this equilibrium that always occurs in water, even if there's other stuff in water. Even if there's other stuff dissolved in water, this equilibrium will always be valid. So we have this equilibrium. So at room temperature, the value of Kw is 10 to the minus 14th. That's a constant, the equilibrium constant. And if H3O plus is 10 to the minus 3, then OH minus concentration has to be 10 to the minus 11th in order to give 10 to the minus 14th value for Kw. So we could solve for the OH minus concentration that's 10 to the minus 14th divided by 10 to the minus 3rd, so that's 10 to the minus 11th. So this is a way to get the concentration of one of these if we know the other, since Kw is a constant.